Welcome to HADOOP Ecosystem. Introduction to the HADOOP Ecosystem. HBase. Let me introduce you to Hadoop, an open source framework that become essential for handling large dataset across computer clusters. So basically, Hadoop it's all about distributed storage and processing, making it possible to manage and analyze big data efficiently. The key components of Hadoop include the Hadoop Distributed File System, or HDFS, which takes care of storing data across multiple machines. And then there's MapReduce, which handles the processing of data in parallel across these machines. We also have Yarn, which stands for Yet Another Resource Negotiator, helping to manage resources across the cluster, and Hadoop Common, providing the essential libraries and utilities needed by other Hadoop modules. What makes Hadoop stand out is its ability to scale horizontally, which means that as your data grows, you can simply add more standard hardware to the cluster, ensuring you can keep up with increasing volumes and processing needs. Hadoop is widely used across various industries, from large-scale data analytics to machine learning and log processing, because it can affect hardware. So what is Hadoop? This is this is the diagram showing some of the tools and technologies included the Hadoop ecosystem. So we want to learn about some components like HDFS, MapReduce, Yarn, Hive, Apache Pig, Apache HBase. What is Apache HBase? HBase is usually used as a data store within the Hadoop ecosystem. Big data store that is designed to provide random, real-time access to big data. Hadoop has two main components. First, the Hadoop Distributed File System, or we known as HDFS, for storage, and the second one, MapReduce Programming Model, for processing data. It is built on top of Hadoop's HDFS and is modeled after Google's Big Table written in Java. This is Apache HBase. So there are some characteristics of the HDFS. It is highly fault tolerant and high throughput, suitable for applications with large datasets, streaming access to file system data. In Hadoop's HDFS, the name node and data node are together to manage and store data efficiently. HDFS component. First, the name node. It is also known as the master node. Name node doesn't store actual data or dataset. Name node stores metadata, for example, number of blocks, their location, on which rack, which data node is the data stored, and other details. It consists of files and directories. So what are the tasks of the name node? It manages file system namespace, regulates clients' access to files, execute file system execution, such as naming, closing, opening files, and directories. So this is the diagram showing the process how the name node function showing the process how the name node functioning. Okay, let's move to the second characteristic or the second component, which is the data nodes. It is known as slave. Data node is responsible for storing actual data in HDFS. It performs read and write operation as per request of the clients. The worker nodes that stores the actual data blocks. Data nodes manage storage for its local file system and serve read and write requests from the client. And let's move to MapReduce. It is a core Hadoop ecosystem component which provides data processing. It is a software framework for easily writing application that process big amount of structured and unstructured data stored in the Hadoop distributed file system, HDFS. They are parallel in nature, so it is very useful for performing large-scale data analysis using multiple machines in the cluster. Therefore, it improves the speed and reliability of cluster. It's this parallel processing. Working of MapReduce, following by reduce phase. Each phase has key value pairs as input and output. In addition, programmer also specifies two functions, map function and reduce function. Map function takes a data set and converts it into another set of data, where individual elements are broken down into key pairs. Whereas for reduce function, it takes the output from the map as an input and combines those data based on the key and accordingly modifies the value of the key. So some features of the MapReduce, there are simplicity. It's easy to run. Application can be written in many languages such as Java, C++, and Python. And secondly, the second features, scalability. MapReduce can process petabytes of data. It can scale into a large dataset. Thirdly, speed. By means of parallel processing problem that take days to weeks, it can solve in hours and minutes by MapReduce. Lastly, fault tolerance. MapReduce takes care of failures. If one copy of data is unavailable, another machine has a copy of the same key pair, which can be used for solving of same subtask. All right, let's move to HBase. Apache HBase is a Hadoop ecosystem component, which is a distributed database that was designed to store structured data in table. HBase is scalable, distributed, that is built on top of HDFS. Provide real-time access to read or write data in HDFS. There are two HBase components. There are two HBase components, that is HBase master and region server. For HBase master, it is not part of actual data storage, but negotiates load balancing across all region server. HBase master maintain and monitor the Hadoop cluster. It performs administration, creating, updating, and deleting tables. HBase master also controls the failover. Whereas for region server, it is the worker node which handles read, writes, updates, and delete requests from clients. Region server process runs on every node in Hadoop cluster. Region server runs on HDFS data node. So this basically has explained why HBase is having some advantages, like providing scalability and fault tolerance, so on and so forth. Who is using the HBase, Apache HBase? Some of the popular applications like Twitter, Adobe, Netflix, Yahoo, Spotify, Uber, Pinterest, Facebook. There are the users of Apache HBase ecosystem. So this is another diagram showing the Hadoop ecosystem in detail.